My name is Jeremy Allison. I work for Google's Open Source Programs Office, but I have to add the disclaimer before the talk. This is not a Google badged talk. No Google lawyers have been harmed in the making of this talk or even seen it. And so please don't take anything here as representatives of Google, its affiliates, blah, blah, blah. You know the legal boilerplate. I'm here sort of on behalf of the Samba team, although this isn't actually really a Samba talk. If you wanted to know the details of how Samba handled this specific issue, Volker's talk yesterday, if you missed it, was an excellent one, and I heartily recommend that you go and find the video and text of that and watch Volker's coverage of what we did in Samba to address this specific issue. So this is not so much a talk, more of an angry rant. And the pun is symbolic links considered harmful is taken from a very famous old computer science paper about gotos. And I feel about symlinks sort of the same way. And I shall explain why. So this is a storage conference, but what I'm really trying to, who I'm really trying to talk to here are application developers who write applications that use storage. So this may not be exactly the right audience, but I'm going to try. Let's see how it goes. So what are symbolic links? I'm presuming everybody knows, but just in case, the reason I included this slide in the beginning slides in this talk is because most users now, most computer users who use phones and tablets or whatever, have no clue what a file is, let alone what a file system is. All applications on your phone save stuff magically. The users don't know where, they don't care. And so they really have no concept of what a file is, or where it's stored, or how it, or even how it is stored. Each application is a silo in and of itself, stores data in its own magic place as far as the users are concerned, which is why you have to have these horrible little share links for users in applications, because that's the only way they know how to share a file or content. There's a great article there explaining how computer science educators now actually have to teach the very concept of a file system to new students coming into computer science, because they've just never run across it before. It's an alien concept to them. Looking at the people in this room, I'm imagining this is not an alien concept to you guys, because you're all old, just like me. So users only these days, they just search for objects by name. They don't even know what it is they are searching. And you know, the evidence of this is I have to help my family move things around from phone to file server. They have no clue where things are, how to move them. You know, the difference between Apple Photos and Google Photos is a mystery. Hey, I took photos, it appeared here, why isn't it over there? Why can't I share to my WeChat? Or, you know. Yeah, it's actually quite confusing for users. So, all right, what's a file system? Let's just step back. And that's a wonderful picture of a upside down tree, obviously in Australia. And so that's that's obviously a very simplified view of a file system. So let's look at the kind of file system that I would have on my server at home. So, you know, all my music is in Home Jeremy Music. Actually, it's mostly FLAC files, but I didn't know whether people were audio files, so I'm using MP3 here. So you have, you know, obviously directories which are oval here, and files which are bags of bits that live inside directories, and you can have multiple files inside a directory, obviously. So now I'm getting application developer specific. So the original UNIX API for dealing with paths on a file system, it's actually really simple. You have open, you give it a path name, you can unlink to remove something, you can make directories, remove directories, stat, all of these things can go from what is considered an existing place that you are in the file system called the current working directory. You can change the mode bits, which are in Unix are permissions. You can change ownerships, etc. You can have an absolute path which starts with a slash, or a relative path which starts from where the current working directory that your application knows where it is in the file system, which is kept track of by the kernel. And this is conceptually very simple, very easy to teach. It's kind of logical. Once you understand the tree structure of a file system and the files being the leaves and the directories being the branches, it's kind of simple to get. So then things get a little more complicated with hard links, and last time I posted this talk, somebody did this talk, somebody posted it on Hacker News, and I got a bunch of complaints about the fact that the LLS should be actually attached to, basically it's in the wrong place. It shouldn't be on the link itself, but it's harder to draw that way. So essentially, when you do a hard link, what you're doing is creating two entries, one inside entry directory temp, one inside entry bin, and they're actually pointing to exactly the same bits, bag of bits of the file. So, you know, if you do a stat on it, you get the same inode, which is how a file is identified on a particular file system. To all intents and purposes, they are the same file. So all that's different is the entries in the temp and the bin directory. So that's hard links. Hard links, you know, are useful, not terribly flexible. You can only do hard links to files, for instance, not directories. Yeah. They points to the, as I said, points to the same file data, metadata. You cannot make hard links to directories because that way you would get a loop. And essentially all you're doing is creating a new absolute path to the same file. And while there is a hard link to a file, the data will stay around. And the first use I can find of that is from the incompatible time-sharing system that was created in 1969. Even I'm not old enough to remember working on that. So now we have symbolic links. So symbolic links are different. As you can see, they create new entries inside directories. And they can appear to be both directories. In that case, we have foo, which is a symbolic link to directory sbin. And in this case, we have a symbolic link bar, which is links to the file user-add. So symbolic links can actually be created to both files and directories. And they are, yeah, well, we're going to talk about this. So, what are they? They're actually just essentially a file in the file system with special flags that cause the kernel to treat it differently when it's resolving path names. So they create a new object, but any process traversing that name, sort of the kernel that's walking through that, the kernel does this on the processor's behalf, allows it to say, oh, don't look here, move to the target that is the contents of the file. Interestingly enough, symbolic links are just literally a bag of bits. That's really why they're files. All they have to be is a text string. They can't contain nulls, but other than that, they can be any text string. They don't actually have to point to a real file or directory. If they don't, they're called dangling links. And you can point them to directories too. And when this was added, they had to create a new error called eloop. And that, I think, for the people who created it, should have been a warning. Danger, danger, you are doing something really stupid. Don't do this. And the first reference to it I found was from Multics in '65, even earlier, but they really became popular when they were added to BSD 4.2. And I love this quote because of the horrible naivety of the disaster that they're about to unleash on the computer science community. Symbolic links have been added to release 4.2 of Berkeley UNIX. All bad things come from Berkeley, of course. This feature frees the user from the constraints of the strict hierarchy. You can tell this is coming from Berkeley, right? That a tree structure imposes. This flexibility is essential for good namespace management. It's also essential for a complete disaster. So yes, creation of symbolic links. So that's what they look like for the people who created them. What do symbolic links look like for application developers? Well, they're a bear trap, just waiting for you to step on. When Steve did his talk a couple of days ago about POSIX extensions, he was looking for a good picture to represent POSIX. And I rather cruelly suggested that he should look for a picture of a dumpster fire. Because this, running into this and having to deal with this over the past 3 years has really soured me on the promise of POSIX. And the symbolic links are one of the main reasons why I think much of the POSIX API is in fact a dumpster fire. I think Volker has the same feeling about fork and other things. But. So why are they so bad? Well, they essentially introduce a race condition to every single application that uses the file system. A race condition that no application is expecting to have to deal with. So they allow a path to be changed on the fly. So it creates a whole time of check, time of use, race condition problem inside the file system. And here is the big disaster. Again, probably Berkeley, hey man, everybody should be able to create their own symbolic links, share the power. Symbolic links are not restricted to administrator or root. Anyone with the right access into a directory can create a symbolic link pointing anywhere at any time. So you no longer have a tree structure. This beautiful abstraction of a tree with leaves and nodes is gone, and it completely breaks the POSIX API. Yes, question?
Can you explain the time of check, time of use issue there?
I will go into that a little later. Time of check means, essentially what that means is you...
No, I understand what it means, I don't understand how it applies there.
Okay, I will explain in horrible detail in later slides. So, here's the first example of a talk to. Right, Berkeley added symlinks. Okay, right, how am I going to deal with these things programmatically? Well, the first change was, okay, well, we need to find out if something is a symlink. So there was an introduction of lstat. Because the goal of the original stat is that it silently and transparently follows the symbolic link without knowing about it. So if you're going to actually create them and manipulate them, you need to know if those things are there. So they introduced lstat. Lstat only checks if the terminal component of a path, i.e. if you've got foo bar baz, it would only check if baz is a symlink. Foo and bar could be symlinks. And so here's the classic time of check, time of use that will rear its ugly head again and again and again and again. So you have a dangerous path, or what you want to be a safe path, and you go lstat. Is it a symlink? Because if it's a symlink, I can't trust it, right? Could go anywhere. And then you do is not a symlink. Oh, thank God, it's not a symlink. I can do my dangerous operation on my dangerous path. No, you can't. So you've done the lstat. You've got the buff. You're about to check whether it's a symlink. Race condition occurs there. Before you call dangerous operation, somebody can replace, so long as they get in before the dangerous operation call, they can switch where that path points to somewhere else arbitrarily on the file system. If you root, this is fatal, obviously. If you can rename dangerous path and replace it with a symlink somewhere else before dangerous operation is called, then the dangerous operation is applied to the wrong path, not the one that you thought. That's the time of check, time of use problem. So, there were no real fixes for this for 20 odd years or so. Well, all right, maybe 10 odd years or so. So, people thought, yeah, sure, it's a race, but hey, can anyone really win it? It's kind of narrow, you have to get in really fast. So if you do a search on the CVE database for the word symlink, I think Volker did the same for his talk, he got a few more than me. There are 1,361 CVEs, critical security vulnerabilities requiring application patches just because of the word symlink. And this, this is not just old applications. You might think, oh, well, now we have these new modern APIs that fix this. Then obviously all symlink CVEs have gone. These must be ancient. No, these are happening now, every day, new ones, up to and including Rust, which had a symlink security whole race in 2022. And so a bunch of APIs got added to POSIX to actually protect you from symlink races. Now my argument here, and I'm going to try and make it to this audience, is that these applications that were added are simply impossible to use. They are too complex, impossible. They're essentially not, they're not for mortals. People can't use them. Just like people can't do atomic writes on POSIX using fsync and fdirsync and whatever, just as those APIs are too complex and too hard for normal mortals to use, the APIs for symlink mitigation are also too complex and too hard for mortals to use. And we still continue to get symlink errors.
But these aren't normal mortals, they're storage developers.
SW's comment is, we are not mortal, we are storage developers. Well, yes. When I gave this talk at Samba XP, it was posted on Hacker News while I was on vacation, which meant the discussion went a lot better than it would have done had I been there and pitching in. And somebody made that exact argument. Well, it's just poor application developers. They're stupid and lazy, and they just must get it right. The same argument that was made about the data sync. And, my favorite, I didn't respond to that, but my favorite response was someone who very pompously posted a response in code and pointed to a GitHub library that he created, said, this shows you how to use these APIs safely. And that was a separate Hacker News link. And I actually followed that and took a look at the library, and I found maybe 10, 15 race conditions in the first glance over the code. And all I posted was, thank you for proving my point. So here are people who think, no, I'm smarter than the average bear. I can use these safely. No, you can't. We have tried very, very hard in Samba, and Volker can give you the full details on this. We think, we hope, we pray that we fixed it, but we're just one patch away from messing it up again. Unfortunately. As I said, these APIs are impossible to use. So how did they start? Well, the first one was, we got a problem with symlinks. Well, all right, let's add a new flag to open. That's always a good bet. So they added nofollow to open system call. And everyone who reads that and sees it says, oh, that's great, no more symlink problems. nofollow doesn't do what everyone thinks it does when they first read it. So the first thing you think of when you see nofollow is, well, that's great. I just add nofollow to my opens, no more symlinks. I'm done. Hey, how hard was that? Then you read carefully and you find that nofollow only protects the terminal component of the path, just like LSTAT. It only finds the last symlink. Well, how dangerous is that? Well, so imagine. Here's an exploit. So you check data MyDear is safe, the classic time of check, time of use. Hey, it's not a symlink. We're great. Now, the attacker renames data MyDear to data out of the way, and then puts a symlink data MyDear to etc. /etc. And now when you open with the nofollow, you're opening the password file or you're writing into it, oh dear, you're writing to etc. password. But what happened? I used nofollow. I should be safe from symlink. No, you're not, because they didn't change password to point to password in /etc. They changed the containing directory to point to /etc. Oh dear. Example number 1. So, okay, well, this is what we did when this was first reported to us by Jan Horn of Google, who was the guy who ended up being behind the he was the guy who found the time of check, time of use races in the Intel processors. He ended up going on to, he cut his teeth beating up Samba and then went on to much, much greater things, destroying processors. But he was the first one who reported this. So what do you have to do? Okay, well, to do it safely, you actually have to change directory into the parent directory. Then you have to check that you are where you thought you were. So you do get working directory. Check that it's the same as the directory that you thought you changed into, because of course when you've changed into a directory, you've pinned it in the kernel, and even if they rename it, you can still find out it's been moved. And then you use nofollow to open it, and then we move back to where we were. And this is what we did to fix the open and make dir races in Samba prior to 4.17. And we had some performance regressions because of this, which again, Volker's talk covers very well. So that's one way of fixing it, and you can do that with the standard open call with nofollow. Doesn't solve all your problems, which I'll go into in a minute, but it's better. We still had race conditions. So then they added open@. So open@ is actually a working fix for this, because instead of having to change into a directory, you can open a directory path, get a file handle on it, file descriptor, and then the path that you access there is relative to that file descriptor. So remember, so long as path has no slash characters and you contain nofollow, yes, question from David. So the question is, if you chdir into a component, doesn't that mean you have to do that for every single component in the path? No, because what you can guarantee, at least on Linux and most OSs, is you have get working directory. So you change directory into the target directory, then you call get working directory. So rather than having to walk the path component by component, you are relying on libc doing this for you. And it walks up the path, and it gives you a canonicalized path. So at that point, essentially, yes, somebody's doing it, just not you. So that makes it somewhat easier to use. You basically... Yeah, on the system call, as Volker points out, the system call trace looks equally ugly, but it means that your code is less complex. You can chdir, you can go do a get working directory, and you can do a string comparison. Am I in the right place? Right? So it's easier to use, which is why we did it. So open@ means that the path, you can open a path relative to a directory. But again, this means that unless you're using open@, you are guaranteed to have race conditions. And also, if path is not sanitized such that it contains any slash components, again, you still have race conditions. So in other words, what's the point of having these beautiful path-based APIs if you can never use a slash in the path? And then, of course, as David pointed out, you have to get that handle on the parent directory. So you have to walk the path anyway to make sure that you are safely using nofollow to get the handle that you need to protect yourself against symlink races. Now you're beginning to understand why I say this is impossible for mortals to use correctly. So, great, we fixed the open problem. What about make dir, unlink, rename, symlink, everything else? So all of a sudden, oh great, every single path-based operation now has to have an @ variant. And some of them just don't work at all, at least on Linux. fchmod@, even though it has a flag saying nofollow, that flag is just documented as, oh, by the way, this flag doesn't work. It will still follow symlinks. Thank you very much. And so the original clean, simple, open, close, API, it's not looking clean and simple anymore. Remember, all because Berkeley decided, hey, man, let's put symlinks in. So look at what's happened to this beautiful API. So path names are broken. No application that uses path names with more than one component is symlink safe, unless you split it and walk it. So Great. Now you've got to take care of splitting and walking a path name for every single application. So, rather than fixing it in the file system saying, let's not do this stupid thing, now all the complexity has been pushed out to every single application running in user space. Great job, guys. But it's still not enough. The attribute calls. Now, the attribute calls, you can say, well, they're not really POSIX, they were kind of added later, but many, many, many applications use them. There's no getExAttrAt, there's no setExAttrAt. You have to open the file. Maybe you don't have, and because of the permissions on extended attributes, sometimes you can manipulate extended attributes without actually having permissions to access the file. So for extended attribute operations, you would still have to do the chdir real path or walk, or in fact open the file descriptor. So, okay, well, how do we deal with this? Let's have some more flags to open. Yeah, open out. Let's put some more complexity in. So they added OPath, at least in Linux. So what that allows you to do is, hey, even though I've got no rights to this thing, let me get a handle on it so I can use it for OpenAT. So it allows you to take a handle on a file or directory that is meant to be passed as the special file descriptor to the at functions. And those OPath handles, you can't read and write data. So all you need is traverse access on a directory to be able to use OPath. So again, look at the complexity that is being added in that you're expecting application developers to deal with. How many application developers do you know that could deal with this? 0. So that's great. OPath would be wonderful for accessing EAs, except that OPath explicitly prohibits accessing EAs because they're an object kind of outside the file system. So I don't know exactly who the Red Hat engineer was, and unfortunately I don't think there's a Red Hat person here, but if they are, please tell me. Great solution is actually used inside the Android source code if you look. It's so poisonous and ugly, I love it. So you open the object that you have no rights to via OPath nofollow using OpenAT. You've got a handle to it, right? Now, and this only works on Linux, of course. This is why the other Unix has died. Who can keep up with this continuous churn? So you then sprintf or snprintf, whatever. I know this is insecure code. I apologize. You need to make sure buff is big enough. Proc self file descriptor number. So now you've got a path name based operation that you can pass to get extended attribute. Great! And you know what? I went crazy seeing if this could be symlink based, because when you do an ls-l on proc self fd number, it actually appears to ls as a symlink pointing somewhere. So I thought, oh, I wonder if you can race that. So I tried racing it, and then I tried deleting the object it pointed to and putting something else in its place while the file descriptor was still open, because it actually, when you delete the object, the reference, the proc self fd, when you ls the symlink, it says point it into the file system, brackets deleted. Turns out that's a completely fictitious and imaginary name invented by the kernel. It has no real meaning, because I thought, well, what happens if I actually create a file called filename space brackets deleted close brackets? You still can't get to it. So it is safe, it's just nauseous, it's just nauseating. It's insanity, it's pure insanity. Depends completely on the Linux semantics. Yes, Volker's question.
More comment on the little fun stack.
Uh-huh.
I tried to do a f-readlink call using that trait.
Ah.
But of course you have the symlink to the object itself again, because this is a symlink. So you have to rely on get another Linux special that you can say f-readlink with a null string gets the read link, gets the link target from your file descriptor that you pass it as given.
So because Volker's comment is, because these things appear as symlinks, you can actually do read link on them, but the only way to actually make that work is by a special Linux, again, Linux-specific semantic, where you pass in null as the path name, and you're actually doing a read link on the file. If you pass in a null path name, When you do a read link, fread link, it's pulling the data out of the file descriptor. Oh, is it? Oh, okay. Sorry, I misunderstood. Right. Oh, of course. So I actually, yes, Volker's point is there is no fread link. That's one I missed in the review of all the new system calls. Yeah, I mean, look at the crazy semantics that you have to do. It's insane. Nobody can do this. Nobody can write this. Imagine your standard application developer working on a platform. You say, oh, hang on a minute. If you're given a path name from the user, remember to do all these things before you can safely open it. It's impossible. It's crazy. So, this is I freely admit I took this from the primer XKCD comment. He did a wonderful XKCD where he talked about different timelines on movies, showing where characters went, whatever. And if you've ever seen Primer, which is a wonderful time travel movie that doesn't mention the words time travel, it turns that beautiful tree, Australian tree, into that. And nobody can deal with it. Just as an aside, if anyone has watched Primer and understands what happens in it, please take me aside later and tell me, because I'm still trying to figure it out. It's a great movie, but... So, as I said, path names are now unusable, all because of symlinks. For any non-trivial application, it is completely impossible for any application to avoid symlink races. Just not doable. And it gets worse, because it's not just code that they write, it's all the libraries that they call written by other people who also don't know how to do this. So it's a disaster. Oh, and here's my spoiler alert we're going to get to soon. Code written by security experts, they mess it up too. So here I'm going to give some examples. So none of these examples are Samba, by the way. We had our own problems, 3 years to fix. So here you've got the directory hierarchy, foo, bar, baz, bibble. And if you do an strace on the set POSIX command on Linux, set facl, using the -r, do it recursively, oh look! What do you notice about the paths set into set x atta? They're raceable. So if you can trick root into running a command to change the ACLs recursively on an area that you control, any of those can be pointed, etc. shadow to write the ACL at any time racing. And that's the command as it stands right now. It needs fixing. I have reported that. Example number 2. And, back when I worked in an office, now permanent work from home, but back when I worked in an office, my next door neighbor was Junior Hamani, who maintains Git. And this came by, and I pinged him and I said, I don't like the look of this, June. And he said, I think it's safe. We've evaluated it, whatever. This was actually from a patch from a Microsoft engineer from Git. And look what they do. Is the path owned by the current user? What do you notice about the lstat and the getUID? The small, the plus where it says return 0. What do you notice about what you can do after the lstat, or any time until they do the dangerous operation? Because this is obviously checked to see if something is valid to access. Oh look, you can change the path. It's not checked for multiple components. June assures me this is safe for the usage that they have within Git. So I did report it, and, but yeah, it's called from ensure valid ownership. It was added as a fix for part of another CVE. As I said, application developers cannot use this. Kernel developers, nobody can use this API. Nobody gets it right. No one can get it right. The third one, sorry, a wall of text, unreadable, but essentially what it shows you is that this is an ongoing problem that is unfixed and, I assert, unfixable. Rust standard language, a standard library. Guess what? Removed they messed it up. This check was implemented incorrectly. It already included protection to avoid recursively deleting symlinks, and it followed the symlink. So there you go. So these are the, the new hip, new, cool kids doing the hip, new, cool language that is supposed to be completely safe. They messed it up. It's not possible to use right. So, and I'm sure a bunch of Microsoft engineers here will be smiling very broadly at this slide. Windows got it right. Windows got it right. Not completely, because you guys still added symlinks, which I assert was a terrible mistake. Now, reparse points aren't just symlinks, they're much more flexible than that, I understand, but that's how symlinks are implemented in NTFS. And here's the one saving grace. Administrator only. Had that been done on Unix in the beginning, yes, you can have symlinks, but only root can create them. None of this would have been necessary. No one's safe from root anyway. No one's safe from administrator. So if you make symlinks creatable only by administrator, you fix the problem. And unfortunately, many applications on Linux, including modern ones like systemd, actually depend on symlink functionality by user, because systemd in and of itself, of course, overly complex, allows you to say, oh, I want to run a service, but only when I'm logged in as this user, and it uses user-creatable symlinks to do this. So, you can't fix this just by saying root only. Yes, question?
So you said that, so you claim that, okay, only administrator is the way to fix this, but you also said something interesting there. Application follows symlinks called reparse points. So basically, when you toss a path into a file API, you give an error back that says, okay, this is a symlink.
So the question is, when you use the reparse point, does the application have to handle it with an error message? And I believe for most reparse points you do, but with NTFS symlink reparse points, and please correct me if I'm wrong, Microsoft engineers, but I believe that symlink reparse points are followed silently in the kernel.
That's another way.
Yes. Well, we're going to get to that. We have options. But yeah, this can't be fixed in this way, at least on Linux. So number 2. Okay, well, here's what we're currently doing. New system call, the Linux way. We already have 8,352. What's another one, So they added a new system call, OpenAT2, or if you're Microsoft, OpenAT-EX, and they added a flags field to it. And you can have resolve beneath, resolve in root, resolve no symlinks. And all of these are designed to restrict symlinks. See the problems with complexity again? So they're all different ways of doing it. So here's the issues right now. No glibc wrapper. Samba actually implements these. Met's added it. I think do we do it for 4.17? I think we do. Yeah. So Met's added it just before 4.17. We have to have our own system call wrapper because glibc doesn't do it yet. It does fix the problem for open. We use resolve no symlinks. You'll have to look up the man page for the exact difference between resolve beneath, resolve in root, resolve no symlinks. Again, just another level of complexity for poor application developers to deal with. But it does fix the problem, but only for open. So once it got posted on the Linux Weekly News, lots of people brainstormed ideas to fix it. And this was an interesting one. Add a process control option that you can set on specific applications, or at least you could set globally when you're logging in, that say any system call that traverses a symlink return e-loop. So it does actually break applications, but it does it in the right way. Problem is, it pushes again the complexity of you got a loop, now what I have to do, and it's a nice idea, but it's basically untenable. Nobody's going to do this.
But it also mimics any enter. All of the other calls. I mean, why does the user have to deal with
Dumpster fire. Sorry, the comment was, it's the same as EINTR, which means a system call has been interrupted by a signal. This is also a POSIX dumpster file of a concept. So this is another one that's kind of interesting. People did kick this around and look at some code around this. You could change symlink semantics. I think that this may be implemented on some kernels. I'm going to have to look up you can change the semantics. It's a mount flag you can set such that if your symlink is owned by non-root, it will only be followed by a process that has the same user ID as the owner of the symlink. And it's more subtle, and it would still break existing applications kind of randomly because you don't know that you're running it under your own UID. And I don't know whether no one is, that last comment may be wrong. It may actually be implemented. Oh, somebody flagged me. So it doesn't fix the problem for Samba because we're root, and we just have to deal with it generally. And also, anyone here who's written an SMB3 user space file server, you have to deal with this. You have to deal with this. I don't know whether you are dealing with it, but you have to. So yeah, it doesn't fix the problem for Samba. So here's a nicer one. There is actually a new mount option, mount no sim follow. This is implemented in the kernel. It's a 2-line change. I looked it up. You can look it up in the kernel yourself. It's a 2-line change. Whenever you hit a symlink in a system call, it just returns eloop. And all right, it pushes it up for the applications. It breaks things in the right way. And I kind of like this because what it enables application developers to say is, look, I don't do symlinks. My code isn't symlink safe. I'm broken. So I can only guarantee you have a secure application if you are running this on a file system that has no symlink follow on the mount. And at that point, you make it the application administrator problem. You could actually, at that point, an organization could say, this set of applications will only be run on file systems mounted with no sim follow. And at that point, you can guarantee you are safe from symlink races. There's a new option for the mount command. I actually tried this in the latest Ubuntu, and unfortunately, it's not implemented, not yet. But it's coming. This is the most hopeful fix. And there's a great comment from an ex-Samba team, now Red Hat security member, Simo Source, came up with a really great idea. It actually uses the oh no follow in a very elegant way. And I kind of like this. I don't know whether we'll ever do it, but it has an elegance to it, at least for Samba. So when Samba starts up, you create var lib Samba mounts. And whenever you parse a share path, you do a bind mount with no sim follow from the path that Samba is going to access to var lib Samba mounts to a mount that's mounted no follow. So in other words, var lib Samba mounts foo share is actually a bound mount to somewhere foo, but it's mounted no sim follow. So at that point, Samba could say, hey, you know what? I'm not dealing with symlinks anymore. I insist on no follow. Of course, it only works on Linux. Doesn't work on the latest Ubuntu, which I tried, and we kind of theoretically don't need it now we have resolve no symlinks. And of course, it's Linux only, so yeah. But I like that. I think that has an elegance to it that at that point, Samba can say, you know what, if you're running on Linux, we can guarantee your security, which would be nice. So the mount no sim follow is probably the best way to solve this. It still works for Samba 4.17. You can still create symlinks. They're just not followed. Normal apps that are running out of your home directory that are going to have race conditions, yeah, they're going to race. Race conditions going to race. But it allows specific applications to opt out and say, you know what, I'm not dealing with this crap. Mount me with no sim follow. And it essentially turns symlinks into Windows shortcuts. So when you run into them, you get eloop, and the application has to follow it manually. So, this is kind of the end of it. Let's eliminate symlinks from our file systems because they are a disaster. They were a bad idea in 82 or whatever it was they were added. They're a bad idea now. We must, I feel like the Roman senator, symlinks must be destroyed, ending every speech with symlinks must be destroyed. But they really must. They really must. Let's get a target of eliminating any symlink race CVEs by 2032. So yeah, that's it. Any comments, questions? And I kind of hit my time. Good.
Is there a reason for that date, 2032?
No, I just thought it was a nice day. You know, we could make it the, what is it, 2030, the end of the time T. Yeah, we could make it that, but that's another set of CVEs. So question.
Yeah, so would a read-only symlink resolve this issue?
A read-only. So the question is, would a read-only symlink resolve the issue? Isn't that the same as having an administrator-only symlink? Well, no, but so long as you. So who creates them? If it's read-only, it can't be changed. Who creates them?
So you can have an attribute as part of the actual file that says that if you're going to create a symlink on this file, then it has to be read-only.
Oh, so the comment is you would have an attribute on a file that says if this file is the target of a symlink, then the symlink that you create to this must be read-only. That doesn't actually fix the problem because having read-only access to things that you are not supposed to have access is still a problem. If you're allowed to get read-only access to etc. shadow, it's still a problem. So if you're running as root, somebody puts a symlink, even if it's one of these magic read-only symlinks, if it points to etc. shadow, that process can still, even if that process says I shouldn't be allowed out of this area of the file system, it can still access etc. shadow. Yeah, another question.
I'd like to go back to the e-loop and say that this is like EM where that you just have to learn how the programs go.
Yeah.
See, so if you do get that,
So.
so you only get an error number. How do you handle it once you get it?
So the comment is, if we use the mount no follow and you get e-loop, essentially all you've got is, hey, this path name call failed, where in the path did it fail, was the question. I agree, that is, you then have to handle it by manually walking the path, which
is fine.
Which you would have.
There's boilerplate that.
Yes, there could be a library function added to say, I got an e-loop with this path, give me back the element in the path that caused the problem, would be the way you would do it.
Yeah, that's how they need to handle it.
Interestingly enough, if you look at SMB, I'm sorry?
Watch my talk. I explained this one.
Oh, yes, Volker actually does cover this in his talk very nicely. The other interesting thing is SMB3 does this really nicely. I know it's a protocol, not an API, but if you hit stopped on symlink in SMB3, as part of the error message, it actually gives you back the part of the path that you couldn't resolve. But yeah, this is POSIX, and it's, yes, question.
Actually, going back to the same question, you can have same attribute having two options, right? Create no symlink and create read-only symlink.
So the comment is you could have two options: don't allow a symlinks to this file, or only allow a read-only symlink. Sure, but to be honest, it's easier to just ban them. If you add things like that, what you're doing is you're adding complexity. And complexity is our enemy. Complexity is the enemy of security.
The advantage as also out of symlink is that obviously you have seen that a lot of UNIX libraries are symlinks because they actually help in versioning. So you can have a lot of.
Oh, so that's a very good point. So the comment is, symlinks are used very heavily in Unix library versioning on systems. The answer to that is root create only symlinks, because anyone who's doing library versioning is root. You don't really do library versioning as a standard application. You're doing that on the make install or the package installation. And to be honest, you will never get your idea past Linux. And Linux, to be honest, these days is the only OS that matters. I'm sorry if there's any FreeBSD people in the room, but just yeah. Sorry. Okay, thank you. SW tells me I'm wrong. He's a FreeBSD person. So thank you, SW, for committing to implement OPath and all the other stuff in FreeBSD. And I'm sure we will be getting that from you very, very soon. Yes, come on. Oh, okay. Oh, so OPath is already there. It's all the other stuff. Okay.
So systemd is fairly new. What is that systemd dependency on user apps?
So the comment is, what does systemd do with users created symlinks? So systemd is essentially the super daemon that's taking over Linux slowly, component by component, that starts different services. And just like the disaster that was the X Windows resource fallback, where it would say, okay, let me look in the users directory first. If I don't find it there, I'll look in the etc. system directory. If I don't find it there, I'll look in my install path. Systemd has the same feature that you can say, I want to start a service. Did the user tell me to do something different with this service? So it looks in the user directory first, and that actually is done by using symlinks that the user has to create, that the logged on user has to create. So it actually depends on user created. It's more complex, but if you actually look at any of the systemd initialization files, you'll see there's a very defined, overly complex, of course, fallback path as to where it looks and how it looks for things. It's almost impossible to understand. I actually tried to change some networking features using systemd, and I just messed it up. I ended up having to remove everything I'd done and reinstall because I couldn't get the services to start right, and that's dependent on symlinks. So.
Is there a tractable path to root only symlinks?
So the question is there a way to get there from here? I believe it would be possible to add a mount option, root only symlinks. Because remember, it's a file system specific attribute. So right now we have the no follow, which means no symlinks, or rather all symlinks are prohibited. You would also, the way to get there from here is to have a mount option on a file system that says, yes, you can create symlinks that applications will follow, but only as root. So that would be a reasonably simple Linux kernel change, such that when you make the symlink call or the symlink@, call, either of the two, it simply refuses, on a file system that has mounted with that flag set, it simply returns e-access unless you are root.
Right, so apps would break.
And that would break, all of these other applications, but it would allow you to have full symlink functionality on a file system mounted with that only root could create symlinks. That would be how you would do it. Yes, question?
What about using a capability instead of requiring root?
So the question is, what about a capability? Yeah, root and capability is basically the same thing.
That would fix your systemd problem.
So the capability, the question is, can you fix the capability with systemd? The problem with systemd by using capability? No, the problem with that is that it's not systemd that's creating the links. It's the user that's doing it. So that would mean the ln command has that capability, and that means anyone can create symlinks and race. Yes, comment,
So
question.
I take issue with saying that we should just get rid of symlinks. I completely agree that the application needs to follow them. But I get that. But I do think that they are a useful management concept that being able, even for the non-administrator, to say, hey, go look at this other thing.
So the comment is, you're wrong, application developers can handle symlinks, because that's what you get when you go down that path.
Well, they should handle them.
They just need to write better code. Yes, I've heard that before.
No, using
Yes, so the comment is,
the tools that they have right now.
well, the comment is use eloop, but that's essentially the same as no symlinks. You could have the same thing by having a magic file name that.
No, it's not the same thing, because you don't get the same functionality without them.
So the comment is you need symlinks for certain functionality. Yeah, the problem is that functionality comes at a cost, and my argument is this cost is too great to bear. So any other questions, or I think we're done. I'm kind of out of time anyway. Anyway, thank you very much.